Chapter 10 and 11 deal with states of matter, solid, liquid, gas, and then gases in particular will be the focus of Chapter 11. Now, some of you missed class yesterday, so I wanted to go through a few things that we did address in class, and there were a bunch of demos. So before you go any farther, do me a favor, download from Edline the handout folder or the handout packet for Chapter 10 and 11, especially the first 4 sides of a page. That includes a list of the demos, some of which are noted here, and as well as a table on the back side of that handout. And then the second handout is dealing with states of matter and part of your homework assignment for tonight. So be sure and print off the first 4 pieces of paper from the packet found in Edline in the handout folder for third quarter, Chapter 10 and 11. Okay, so the first demonstration, you might also get a few things handy if you can. Get a balloon if you have one around, or else try to visualize this. I'm sure you can. Get a little bit of water, and I'll talk about the rice. You probably don't have to get those materials together, but I think you can understand what I'm talking about when I go to that point. All right, so you take some water, squirt it on your arm, and how does it feel? Does it feel hot or cold? Go ahead and do that. See if you can answer the question. And then try to understand whether you think that temperature change that you feel, is the water going through when it's going from a liquid on your hand, and then it turns into a gas, doesn't it? It evaporates, the water on your hand dries eventually. Is that an exo or an endothermic process? And the fact that water on your arm or on your hand is evaporating is similar to what happens when we sweat. Now, when we sweat, our bodies produce a lot of heat. And sweating is our way of cooling down our bodies, isn't it, if you think about it? And if you ever are in a situation where you stop sweating, you could run the risk of having heat stroke. Why? Because the water evaporating off of your skin is the means by which our body cools down. I think you've experienced that before. So let's apply that to how we would write that change in chemistry. So the phase change for this physical change is going from liquid water to gaseous water. And does that water gain energy or lose energy in going through the process? That's right. The water has to gain energy or absorb the energy. That's called an endothermic change. And that makes the water evaporate. Well, from where does the energy come? Your arm. So think about that. Your arm lost the energy, and that made the water evaporate. Now, if your arm loses energy, then your arm feels cold. But in a way, there really isn't anything in particular that we could quantify as terms of cold. Cold is really just simply an absence of heat. When you're cold, you don't gain coldness, you lose heat. And that heat is is a form of energy. Okay. 2 examples. One, I've got it written up here. Think about perhaps a father or uncle who has gone bald. They didn't gain baldness, they lost hair. Same thing applies to energy. You gain and lose energy, and that object that has gained energy would become warm, oftentimes, or if it loses energy, often that object will become colder. Same applies to money. You gain money, you have more money. You lose money, you're not gaining debt, you're losing money. I think baldness is a better one to relate to, though. It's a little bit funnier. All right, the next thing that I want to address for us is something that has been sitting on the front of the room on a table for quite some time, about 3-4 months now, and that is the drinking bird. These two chapters are perfect for understanding how the drinking bird works. What causes the liquid to go up in the drinking bird? Why does the liquid rise? Well, think about that question in terms of a straw. Take a straw and put it in any liquid, and what do you do to get the liquid to go up the straw? You have to change the pressure in the straw, right? And the way that you change the pressure in the straw is by sucking some air out of the straw. Less air inside the straw, there's lower pressure in the straw, and so the liquid goes up into the straw. Now, if you think about it, the air around us is constantly pushing on us, on the liquid. We feel the air pressure all the time. We may not notice it until we experience a change in pressure, and that change of pressure we might observe when we climb a steep hill or go up in an airplane, or if we dive down deep, we can feel the pressure, not only the air around us, but the water above us. So we're used to this pressure, but it's hard to grasp. One other way that we can think about this pressure is by thinking about how a vacuum cleaner works. The word vacuum really implies very low pressure as well. And so a vacuum cleaner works by a difference in pressure. It's actually the air around us that pushes the dirt and the loose particles on the floor up into the vacuum cleaner, because inside the vacuum cleaner is low pressure. Outside of the vacuum cleaner is air pressure, and that's a higher value than inside the vacuum cleaner. So it's a difference in pressure that sometimes causes movement, and that's what applies to the drinking bird. It's a difference in pressure that causes the liquid to rise up the drinking bird. But in this case, the difference in pressure is not because we've changed the amount of air in this bird, because it's a closed system. This whole glass tube of the bird is entirely sealed. And so it's because the bird's head is wet. Why is it wet? Because he's drinking water. And what does a wet head do? Changes the temperature. Why? Because the water's evaporating. Let's go back. Remember that evaporating water causes our arm to be cold. Why? Energy is removed from the top of the bird's head, making the top of the bird's head cold. So the top of the bird's head is cold because water evaporates off of his wet head. Now, the thought is, or the question that I have for you, and we're going to have to wait on this for a while, but perhaps you can think about it from a practical standpoint. If the temperature is colder, what does that do to the pressure? Well, guess what? If you haven't ever checked your tires in the winter versus in the summer, you might want to know, especially now that you're driving, if you've just started driving, that in the winter the tire pressure tends to be lower because it's colder out. Why? Because molecules move slower when they're colder. The colder the temperature, the slower the molecules move. The slower the molecules move, the lower the pressure. So why does the liquid go up the bird's neck? Because of lower pressure. Why is the pressure lower? Because the temperature is lower. Lower temperature, molecules move slower. They move slower. They push on the glass less often. Lower pressure. Why does it tip? Oh, that's just a center of gravity thing. Gets too heavy up here. Got too much weight in his head. The center of gravity will shift and then the liquid will flow back down into the bottom of the bird, and then he'll right himself again, and the process begins over and over. So how do we, or what do we do to record some of this? Well, you have a table in your handouts that you've printed that is a summary of the demos, the observations that you make, and you could describe this drinking bird, the concepts that relate to chapter 10 and 11. Well, there's phase changes. That's what the delta means. There's changes in pressure and changes in temperature with regard to the drinking bird. What are the changes going on? A liquid is turning into a gas, and there's pressure and temperature changes. But what stays the same? Volume. Graph, let's pause on that for right now. The explanation, see if you can write down and in your own words the explanation that we just went through. VACBAN, you're going to have to see that to really understand it, so you might pop in sometime when I'm free or when you're doing group work over the next couple of days and see how VACBAN works. I don't really want to take too much time on this podcast going through it, but it's a way for you to understand the difference between liquids and solids. Kind of relates to the idea of rice. You can take rice in a container and pour it, much like you could pour water. But if you could pack it down, it would behave more like a solid whose particles are rigid. Liquids have more fluidity to them. So you'll be reading about that difference in the beginning of chapter 10, I believe. All right, so that concludes the podcast. Let me go back to the demo here page. That concludes the podcast for today. What is your homework? Look on Edline to see which problems in chapter 10 to do. I believe they are on page 353. Those about 6 problems on page 353. Well, let's see if I can find them for you. 3, 4, 6, 10, and 12, I believe. 3, 4, 6, 10, and 12. I think I'm missing one of them. The second thing that I want you to do is in the packet that you downloaded from Edline. It would be the third piece of paper. It's entitled Changes of State, and on it there is a table that has hydrocarbons with oxygen in them, and it asks you some questions about temperature. So if you can complete the front side of that handout and bring both of those things, your your having viewed this podcast, and then the answers to the first page and your homework from chapter 10 to class tomorrow.